Hi, this is Bharat Baruajo. I'm presenting my understanding of the solution for the assignment. So the first we're gonna do is exercise one. So the solution for this, the data inspection is, the first we're gonna do is, we needed two packages, sklearn and the matplotlib. So this sklearn is an open source software of the Python, and matplot library is also open source software of the Python. So here, the first thing we're gonna do is the load the data sets of the diabetes from the sklearn library. So and storing the features of the values which the diabetes underscore which is gonna features, which is like a features, and the diabetes underscore y is like labels. So here, after that, we're gonna check the dimensions of the x and y, the diabetes underscore x and the diabetes underscore y. So here we're gonna do is dimensions. We're gonna check the dimensions, and to visualize and inspect the data, the data of there where the total of the 10 features. So in order to visualize them, like the plotting, and then we're gonna reduce those two features, the 10 features, into the two principal components using the decomposition.pca function, which we gonna see here. Here, yeah, the pca function, uh the PCA functions. So getting into the code. So first we're gonna do is load the diabetes from the sklearn. And when we are loading the diabetes data, and we are getting x and y values, so x and y values. So here, yeah, x and y values, as we have given, is equal to true. So here, if the return of x and y values are true, uh, it's going to return a tuple. So after printing that one, we get a 442, and the it's going to return a tuple and the two-dimensional array. So the first one will be a features, and the second one array will be with the label. So we're gonna do is gonna load the first element of this arrays into the diabetes of x, which means we are going to load the features into the x, and the other one is which we're gonna, the second array we're gonna load into the y. So which labels are which which we're gonna see as labels there. We're going to print the shape of so like as I already said, the diabetes which features are like 10 features total. Here we getting a 442, yes, 442, the data set points, and then each point will be the label as like they're like 442. And it's also printed out the first array, like the features mean like the 10 features of the first label. We are going to come back to the later. So the second we are going to reduce, like I've already said, going to reduce a high dimensional, yeah. The feature space is high dimensional, which is greater than 3D, is which is difficult to visualize. So here we're using the feature space like 2D, which we're gonna use a technique like the principal component analysis. It's like a PCA. So by implementing the function, the diabetes underscore x, where we specifying the component should be the 2, and means whatever the future we go, what are the future the features we have, like it doesn't matter how many number of features we had, it's going to reduce into the two principal components. So we said the 2 here, it's going to be reduced those 10 to 2 principal components. Two components, yes, here, yeah, the two components, the 442 datasets points with only two principal components. So in order to like provide the exact thing what the exact happening here, as when I printed out the first column, I mean the first the column and the diabetes data we here diabetes, the principal components that given out of these two values is features converted into the two principal components. So mat yeah, let's see the matplotlib, the plot the x underscore 2d which produces figure one. Yeah, after getting a figure here, uh yeah, the figure shows it's a visualized inspection of the data set. Okay. Yeah. After that, we use MATLAB to plot here. So we use the plot function of the subplot, which the figure ratio is 8 to 6. So and the DPI and here we use DPI is 80. So we use a scatter function. So x underscore 2d, which we have already taken, is 0 and 1. Um, which we here we use as a scatter plot. So the principal component 1 and 2, which we label as a set function, set function. So here the label one is the label one is principal component 1, and the x label the y label is principal component 2. So here for the visualization for the title we given is a visual inspection of the data set. So here the blue dotted lines are the plot visual, the data set of the diabetes. So coming next to the label conversion. So here the data underscore y is not a numerical. It's are numer. Sorry, the data diabetes underscore y are numerical. It's not a categorical. So to convert into the categorical, we have to perform the classification of the regression. Instead of regression on the data set, we used to convert the label from the numerical format to the categorical format. So here the machine learning, commonly adopted machine learning as a classification is easier, which will be easier in than regression. Here we use regression for this. Here after here the conversion method, the method is the average value, the mean values of the underscore value we create, and we have to compare to the binary values, which the binary value should not be greater than 1. So here the binary labels we have given as 1 and -1. So so here for y here we are representing as 1, and diabetes underscore y which is greater than the mean value we represent as -1. So here coming to the code, we import the numpy as np from the library. So after the diabetes underscore y is like a numerical category, which type. So we have to print that and then calculate and separate into the classes. Here we are using the num dot average values, like a mean values, data underscore y. So it is assigned to the data, the diabetes underscore the mean. So here underscore or y underscore binary, the num values array. If one, here we are using the if function, if else function. If the I is greater than the diabetes underscore y, so one will be printed. So here the -1, the value of -1 is the value of -1 if the I value is less than or equal to -1. This -1, the diabetes of underscore will be printed. So here after getting a printed, here we getting a -1 +1 -1 +1. This is the order which we gonna see. So after figuring all these things, we are assigned AX values, which we included plot and subplot. The figure size is same, which we're gonna take in the which the previous one. So after we are here, we are using a scatter function. So x underscore 2d 0 and binary, as I already said, 0, which I is greater than 1, will be marked as +1 here, and the scatter underscore 2d is the here -1. So the binary function, which the mean function is less than the -1, is marked as the x. So here the x label as principal component 1. Here the principal component 2 is which is gonna label y label. So the given visualization representation, for the visualization we have named the title as a visual inspection of the data set with the binary labels. So here the x is, here the x represent, or the orange x represent the -1, and the blue, the plus sign, represent the it's 1. So comparing these two, the both are equal, and so here the output is the output which after writing the code we got an output. So here after that thing, first we have to generate the one data set using the following code. So here what we have, so here we are not using a diabetes data set for the for this particular exercise. So here we are using a range of 150 and the 2 dimensions. And we are using an array. Coming to the code, we have to write a function and describe the above. So here the definition, and we have to generate the data function, the data generate underscore data function. X is equal to np num array. Here we are using I multiplication np into pi, which is equal to 3.14 divided by 180. For here the given value is 1 and 150, and the dimension is 2, which the all these the values is will be assigned to the x, and the x is loaded and into the sign, which is loaded into x. So here sign of x, so here num into sign x plus the num random and normal values. Here we are taking 0 and 0, and the 15 and length equal to x, which will be the all these values will be assigned to the x. So here we are taking the length. So and the x and y, the data x and y. So here we are giving the data will be if that will be getting error or something true, or getting error, we are getting a written value. So after generating and printing, yeah, the executing the code, the data underscore x, the data underscore y will be a generate value. The generate value will be x and y. So after printing this thing, we are getting a 75 and 75. So, and here we are using a 40, this is seed equal to 42. It's a random state of number, which we're gonna like we are taking a random number. So here we have taken a 42 random dot seed, the seed seed here sorry first we're gonna import the random function from the select function, the model selection, the underscore selection. So import we're gonna import and name as the train underscore test dot split. So all though, so we have set a seed here is equal to 44 or 42, and then the num random we have selected as the 42 will be assigned in the seed. So we are taking the num and random of seed. So after that the x the train of x, and the x underscore train, and with the test underscore same we're gonna write like this, the data underscore x, the data underscore x and data underscore y, we are taking the test size is equal to 0.33. Here the random, the first we have taken is a seed, that's a random seed, and the x underscore train will be printed, which we can assign this dot shape, and same as y. uh, and here we are getting a 50 for the underscore a train, and for the x underscore train is 50, and the y underscore train is 50. And here the test also for 25 25, and the train shape, dot shape, here we got 51 and 51 and 25 and 25 1. So here the linear regression, coming to the linear regression, we are from the library, we import the sklearn linear dot model. So here LR indicates the linear regression function. Here training a linear model, that's just its the x underscore train, which we have already said, and y underscore train, which is assigned to a fit function, which is linear regression. So after printing and executing the function, we are getting the coefficient of the value 0.169 and something, and and the value of 0.46 is the intercept. So here we're getting the error prediction on the training set. So the linear regression dot score function we have taken for the same as x underscore train and y underscore train. So we are taking the prediction of the train underscore error we are assuming, and so for that we are taking a train and the test function, the both will be assigned for the test error. So after printing and executing the code, the train error, the value will be 0.204 something, and the test error will be 0.03. So here in this visualization, we're gonna see the blue color dots as a training set, and the orange denoted visualization dots as a test set. So the red line which divided here is a fitter line. So here, so coming to the code, here we are using a coefficient and intercept. Here we are also using RR, which is a rate function of the alpha is equal to 10, which is denoted. Okay, and the same as we are taking a ratio of size 8 to 6, and a plot of subplots, and here we are taking 100, the same as we do. Here we are getting a scatter function, the test will be set, and we are denoted as a ax dot set underscore x label. We are labeling as a x, and the label of y for the visualization we denoted as y. And after running and executing the code, the function is 0 0.5 and y. So here the blue dotted line is test training set, and the orange denoted values is test training set, and the blue denoted values is training set, and the orange denoted values is train set. So the in this visualization, the red line is divided into the separated by a fitter line. So here both are same. Okay, so coming to the code, from the sklearn library, we are taking a range function which is imported. So we are taking the alpha values as 100, 100 and 1000. So and next we are taking a subplots. The size of subplot is 8 to 6, and the DPI is 1, and we are taking a training the scatters function. which the label name is training set, and this the next one scatter function will be a label of y, which is denoted as a test set. So here we are giving a red, green, and brown colors. So here we iterate over alphas. We are taking a loop here. So I is in range of alphas. So alpha is equal to alpha of I. Here the I is printed. So the function we have taken in the new line for alpha is alpha in the flower bracket alpha. So we are taking a ridge function here. The alpha is denoted into RR. So after that, the fit function is multiplied to RR. So the print function, after printing these function values, it shows alpha 1 is the train value is 0.472, and the training error is 0.203. The test error is 0.33. So after the same will be executed for the 100 and 1000. So after printing the test error, the train error here. So, and after that we are taking a legend function ax, which is assigned, and for the visualization here we are labeling the x value as x and the y value as y. So the plot here show function, it is denoted to the plot. So for the 100, the trade value is 0.64 and the training error is 0.08. The test error is 0.100, the decimal values. So for the 1000, it's also it's like minute changes. So coefficient value here is 0.0047, and the test error is 0.001. So after running this code, the pixel visualization here is the red line divided by the orange, and the blue lines is the alpha is equal to 1, which gonna take alpha is equal to 1 value. So the green line is alpha is equal to 100, and the red line, sorry, blue line is 1000. So here blue line denoted as a training set, on the orange denoted the dotted lines are test set. So as function, the both of these values, comparing all these values is the alpha increases, the errors get the smaller. In this pixelization and the code, the all this code looks like same, but the value of alpha, if the alpha value increases, the error code, the error of the values get smaller. So alpha, when the alpha is equal to 1, corresponding fitted to the line, as a ordinal linear regression will be occurs. So here is a presentation which is gonna understand. Thank you.